So in this session, we are going to perform experiment number 5, that is performance characteristics of DC motor angular position control system, that is manual control. Okay, so our aim is to study the performance characteristics of DC motor angular position control system. Okay, so what are the apparatus we require? We require one DC position control system. Okay, then these are the theory part. So this is our main circuit diagram. Okay, so here if you go through the circuit diagram, so here we have one command type potentiometer, and here is one response type potentiometer, and one DC motor, and for to take the feedback for that purpose this tacho generator is used. Okay, then these are the gains of your motor gain constant, and this is tacho generator gain constant. Okay, and this is one error detector. So this potentiometer can be act as a error detector. Here we have used one pair of potentiometer. Okay, so in order to understood how the position of DC motor shaft is maintained, angular position of shaft is maintained. Okay, so once again I can give you the theoretical part, how this circuitry actually works. So we have already discussed the example in the theory class. Okay, so we just go through it. Okay, so here this is the example, similar example you will get, so that you will get the idea how this DC position control system work. So here in this example, this is the best example of position control system, generalized one. So in this position control system, we have to maintain the position of this shaft. Okay, so in order to maintain the position of this shaft, so here we have used one pair of potentiometer. So this potentiometer B and potentiometer A can be act as a reference. So corresponding to reference, we will get the angular position theta, angular displacement theta r, and with respect to the desired position, or we say that control actual position, we'll get the angular position displacement theta c. C stands for control, R stands for reference. Okay, so the shaft whose position that you have to maintain, which can be directly attached to the control pot, and this is the reference part. So we can adjust the position of this reference part, whatever the desired position we require, or we have to maintain the shaft position. So according to the reference, the position of the shaft has been adjusted. Okay, so if slider arm A position and slider arm B position is at same position, then the error voltage is 0. Okay, so no voltage is amplified, and again no signal is provided to the motor, and hence your shaft can be maintained to same position. So as soon as the theta r position is changed, so there is a difference between theta r and theta c. So according to the difference of theta r minus theta c, we will get the error voltage E. So the error voltage is amplified, and again your motor can drive the shaft, and new shaft then shaft can achieve to new position. So in this way, in general this example works. So same way our practical circuitry is going to work. This is our theta r and this is our theta c. Okay, so if there is a difference between theta r and theta c, there is a generation of error voltage, and then that error voltage is amplified by multiplying the gain Ka, and according to that the motor shaft position has been maintained. So same way this example is going to work. Okay, so I can show you the practical demonstration of it. So what are the observation table that we have to measure? So we are going to measure theta r, we are going to measure theta 0, and corresponding to theta r and theta 0 will measuring the electrical voltage. So this angular displacement can be converted into electrical voltage. So we are going to measure VR, and we are going to measure the V0 value with the help of probes. Okay, so you just go through the observation table. So here theta r is the angular position of reference pot, then it is in degree, difference we are determining. Then theta 0, angular displacement of output port. Okay, there in difference, the theta r minus theta 0 difference. Then correspondingly electrical voltage VR and V0 and their differences. And we are going to take the readings at different values of gain K. Okay, so this is a simple observation table. Okay, so we just go to the panel. So this is our experimental kit, that is DC position control system. Okay, so over there this DC position control system. So this will be our reference port and this will be our output port. Okay, this is the motor in it whose shaft position that we have to maintain. Okay, then this is our circuit. So this is the error data. So this is port, reference port, and this will be our actual port. Okay, so and their difference error difference is taken over here. Okay, and this error signal is provided to the motor. So here motor and tacho generator are mechanically coupled. So this will be your output port here, and that signal is provided over here. Okay, and these are the values for adjusting the gains of motor gain as well as the tacho generator gain. Okay, so you can adjust the gain and accordingly take down the readings. Okay, so initially you see this here, the reference port position is adjusted to 130. Again, similarly, the actual position of motor is again at close to 130. So slight error will be there. Okay, so close to 130. So here we are going to take down the readings for. So now here is the DC position control system. So as you change the position of reference port, accordingly the output port is adjusted to same position. So that means it can maintain the sharp position. So how it can be maintained? You see this. So I am initially it was at 130. Okay, so I can change it to 150. You see this, as I have changed it to 150. You see this again. This motor shaft is also changed to 150. So that means it can automatically adjust. So how it can automatically adjust? So as the reference port is changed, so there is a difference between theta r minus theta 0, and according to that, error signal is provided to the motor, and motor can move the shaft from 130 to 150. So same way again we can, you just observe this another reading. So I have changed to 170. Again, you see this, the motor shaft changed to close to 170. Okay. So again, I can go to 190. Okay, I have changed the reference port to 190. So again, here we will get 190. So in this way, automatically the position of the shaft has been maintained. Okay. So this is all about the DC position control system. Okay, so I will give you the sample readings of it. Okay. So here these are the sample readings. So here we have adjusted the value of KB to be 9. We just note down the readings and plot the graph. Corresponding to theta r and theta 0, we have measure VR and V with the help of probe.